Hey guys, Easy Science here. Studying for an exam or just learning for fun? You've come to the right place. Today's topic is on trigonometry again, but solving for angles. Last video we did solving for sides. Seemed pretty easy, right? You just do the normal sine or cosine, tangent, solve for the side using algebra. If you try that with an angle, you'll get nowhere. You have to use a different type of function or trigonometric function. It's the same base, but a bit different. So these are called inverse trigonometric functions, as seen here. Like you might know with functions, normal functions, to say it's inverse, you just put a little -1. Let's try with f. With f of x, to state that it's an inverse, you would put a little -1 notation there. It doesn't really mean that it's 1 divided by f of x, not the negative exponent. It just means it's the inverse. So there's a chart here. X, let's say we have a variable x, and it's equal to the cosine of theta. Cosine of theta. What does that mean? X is equal to adjacent over hypotenuse, right? Easy enough. For inverse trigonometric functions, it's different. You're solving for theta, which is the angle. Theta is equal to cosine of -1 of adjacent over hypotenuse. So you're taking the value you got from cosine, which is adjacent over hypotenuse, but putting into the negative first, which is not all, into the inverse function, and then you get the angle where you can get this with the cosine. So imagine it like this. If you put something into cosine, let's say some x to cosine, you get your ratio, right? You get cosine of x, which is your ratio. But in this one, you go from cosine, or your x here will be basically your theta. Like, let's say this is more theta. You put theta in here. Oh my. Oops. So you put your theta into there, into the cosine function, and you get cosine of theta. But differently, for cosine, if you put cosine of theta into the cosine inverse function, you get theta. So you're putting it into a function that brings it back to its original state. Interesting. It could be written as cosine or whatever at -1 of x or theta, or it's the same thing as the arc cosine of x, or arc tangent. Same thing goes with the arctan and arc. Yeah. So I have an example here. So I've constructed a problem here. You're trying to find what angle A is. Trying to solve for angle A. And you know two sides, BC is equal to 8, and AC is equal to 2. Interesting. How can we find what angle A is? If we go through our base again, where you have to insert what you get, we know that this is the tangent function, because we don't know the hypotenuse, so it can't be the sine nor cosine, so we have to stick with tangent. So tangent of our angle A, or let's name it theta, angle theta is equal to 8 divided by 2, which is the same thing as 4. Whoa. Now, we've gotten our ratio of the tangent. Now to find the angle, we just plug it back in. So, let's get our arctan function out. Arctan, or tangent to the inverse tangent. What are we plugging in here? We are plugging in here our value from where we got our tangent of theta, which we can call x. If we plug x into here, it's going to be arctangent of 4 and tangent, inverse tangent of 4. Now, I don't think anyone can possibly get this in their heads. So, So what is this equal to? Let's get our calculator out. Okay, thank you Web 2.0 for letting me use this calculator. So if we press to the second, which just brings another column, we see that there's a tangent, or we could just type a tangent. So tangent, inverse tangent of 4, if we write it, equals 75.96 degrees, which we can round up to, let's just round it up to 75.96 degrees, which is equal to 75.96 degrees. Okay, so in this video we learned what the inverse functions are, or some of them: cosine, sine, tangent, those in the inverse, which can also be arc cosine, arc sine, arc tangent, and we learn how to solve for angles. Now let me give you a problem to do as a bit of homework. Type it in the comments below for the answer, or just type it in, and I'll give a thumbs up and shout out to who got it right.